unpredictability. The milkman, the paperboy, evening TV. Did I get delivered here? Somebody tell me, please. This whole world's confusing me. Clouds as mean as you've ever seen. Ain't a bird who knows you're true. Then a little voice inside you whispers, kid, don't sell your dreams so soon. Everywhere you look, everywhere there's a heart, a hand to hold on to. Everywhere you look, everywhere there's a face of somebody who needs you. Everywhere you look, when you're lost out there and you're all alone, life is waiting to carry you home.
Thanks for coming to class today, guys.
So today we're going to find the angle of elevation when lengths are known. So the height of a basketball backboard is 12.5 feet and the shadow is 17 1/3 foot. So let's just draw that. So this is going to be 12.5 feet. And this is going to be 17 1/3 feet. But we're going to convert that to inches. So this is actually going to be 150 inches and 208 inches. And it's asking what the shadow is. So there's a sun and the shadow. So I need to find this. And this angle is going to be theta. So we're going to have, the backboard is going to be right triangles because you have to use right triangles to solve for this. And this horizontal line is going to be really important. And so we're going to do theta equals the inverse tan of 150 inches over 208 inches. You're going to enter that into your calculator as inverse tan 150 divided by 208, and that's going to give you approximately 35, this is approximately 35.80. Alright, so that's how you do that problem. So now we're going to find this function value. So we don't know this side, so we got to figure that out with Pythagorean theorem. Maybe remember it from geometry. So you're going to do root 3 squared plus b squared equals 2 squared. So this is going to be 3 plus b squared equals 4. And then minus 3 b squared equals 1. Take the square root of that, and you have b equals plus or minus 1, but only the positive one matters. So you have b equals 1. Now that we know b equals 1, we have to figure out angle theta. So we know that we're going to reflect this over. So let me draw a new picture. We're going to reflect it over like this. And this is 2, this is 1, this is 2, and this is 1. So that's reflected over. And this is what the angles look like. So this is 60 degrees, 60 degrees, 60 degrees. So all lengths are the same. So that means all angles are the same, and all triangles have to equal 180. So that's how we know that these are all 60 degrees. And each angle equals 60, so you have to divide 60 divided by 2, which equals 30 degrees. So then, to get what that theta angle equals, you're going to do theta equals 60 degrees divided by 2, which equals 30 degrees. And to put it in radian, that's going to be pi over 6 radiant. And that's how you do that. So that's going to be B equals 1. Cole, did you know that? We're going to find the sine, cosine, and tangent values for angle D and E below. So this is what the problem triangle is going to look like in the problem. So this is 36, this is 77, this is 85. And they were all previously given. And this is a right angle. So this is F, E, and D. So, right triangle, we have to use SOHCAHTOA definitions. So, the sine of angle D equals opposite over hypotenuse, and that's going to be 36 over 85. The cosine of angle D is going to be adjacent over hypotenuse, and that's going to be 77 over 85. The tangent of angle D is going to be opposite over adjacent. Which is 36 over 77. So those are all for angle D. Now we're going to do the sine, cosine, and tangent of angle E. So sine of angle E is going to equal opposite over hypotenuse, which equals 77 over 85. The cosine of angle E is going to be the adjacent over hypotenuse, which is 36 over 85. And the tangent of angle E is going to be opposite over adjacent, which equals 77 over 36. So notice, since sine angle D and cosine angle E are equal, they're both 36 over 85. Remember, because measure of angle D, so measure of angle D plus measure of angle E equals 90 degrees. Since we use 90 degrees in our triangle, the other two need to be complementary, which means equal to 90 degrees. So just a little extra, measure of angle E equals 90 minus measure of angle D, and the sine of angle D equals cosine 90 minus D. And these are all of your cutes. Finding the reference angle, so our problem is 460 degrees. So we're gonna start here, and if we go all the way around, that's 360 degrees. And then if we keep going to this line, that's gonna be 450 degrees, but we need to go to 460, so you're gonna go a little bit more, and that's going to be 460 degrees. But we need to find how many degrees is this angle. So had we gone all the way to the x-axis, we would add 90 degrees plus 45 degrees. And if we look at the terminal, 540 degree ray and positive angle, because once we go past this you're in a negative, positive angle it makes with x-axis. So to find this degrees of that angle, you're going to do 540 degrees minus 460 degrees. And that's going to give you 80 degrees. And that's going to be your reference angle. So we're going to approximate the value of each of these expressions. So our first one is going to be tan, or tangent, 68 degrees, 43 minutes. So make sure your calculator is in degree mode, it should say in the bottom right. And then if you don't, you just go to mode and you change it to degree. So you're gonna do tan 68 plus 43 minutes divided by 60, because there's 60 seconds in a minute. And that's going to approximately give you 2.5670. And that's easy to do on your calculator. You just do tangent 68 plus 43 divided by 60, and that's what you get. So that's how you to approximate the value of the expression.
For this problem class, we're trying to find the complementary and supplementary angle. Complementary equals 90 degrees. Supplementary equals 180. A good way to remember that would be to make the C into a 90 for 90 and the S into an 8 for 180. So to find X, all you have to do is 180 minus 120 equals 60. Sam.
Set.
Okay, for this problem class, we're trying to find the coterminal angle of 60. So all you do is go all the way around.
It's 300, duh!
Ben, please be quiet. So then you do 360 minus 60 equals 300. And that's how you find the coterminal angle of 60.
Monday, happy days. Tuesday, Wednesday, happy days.
Okay, for this problem class, we're going to try and find a quadrant of 180. Alright? Okay. Alright? Okay. So 120 is in quadrant 2. Alright? Okay. Alright? Okay. For this problem class, we're trying to find this unknown side A. So first, we define this angle B. 90 plus 36 equals 126. Then all you have to do is 180 minus 126 equals 54. So the angle is 54. Next, you put the unknown angle on the top, and the known, or the unknown side on the top and the unknown on the bottom, 10. That equals sine of 36. Then use the trigonometric table to evaluate the expression, to evaluate the function, which is 0.588. Then solve the unknown. A equals 10 times 0.588 equals 5.88, and that's the length of the side. Paloma, did you get that? Paloma, wake up.
What?
For this problem class, we're solving the right triangle, given these two sides. So first, you use the Pythagorean theorem to solve for b. So 8 squared plus b squared equals 12 squared, which then equals 64 plus b equals 144. Next, you do 64 minus 64, and then 144 minus 64, which gets you 80. So then b squared equals 80. Find the square root, and the answer is b equals 8.9. That's the first part. So next, we use the sine of A over 8 over 12. So then you use the inverse of sine, which is -1 equals sine -1 8 over 12. And all that equals 41.8 degrees. Then, so A equals 41.8 degrees. Then all you have to do is 90 minus 41.8 degrees equals 48.2 degrees, and that's how you find angle B. And that's how you find all the sides of a triangle. Okay, class, stay in your seats till the bell rings. And I have a surprise for you, class. David!
Bonjour, class. Baguette.